Welcome everybody, thanks for coming. If you were at Tim McKay's opening talk a couple of weeks ago, you saw the slide, or if you've seen Tim talking about learning analytics, he almost always uses this slide as an opening slide where sun shines to the diag, and the whole idea of learning analytics is to sort of provide light to what we're trying to do. When we're talking about teaching evaluations, it's usually more like, holy cow, I'm facing 300 students who are looking at me eagerly, what am I going to do and how is this going to go? That this was more appropriate. This is from my intro political theory class from the first class this semester. They're still eager, they still remain that way, but we'll see what happens. So this talk is going to be, we're going to be sharing a bunch of data with you. It's not our final word on these things. And so I welcome questions and comments throughout the talk. There will be time for Q&A at the end, but I welcome questions and comments because some of the stuff is going to be really interesting, I think. We chose to present sort of lots of descriptive data, hopefully accessible visually. And one of the things we'd like from you are questions and suggestions of where to go from here. There are lots of limitations on what we have at the moment, but again, I want this to be an interactive project. And Mary mentioned my affiliation with philosophy. My PhD is actually in philosophy. I'm a political theorist. I'm as far from big data as you can get without turning to German. And so I'd like to say, if you have any problems, blame David, but that's actually not true. Blame me. There'll be a lot of you here who will know much more about big data than I do. But so the teaching evaluation project that I have been spearheading or leading for about the last year, it's part of the Learning Analytics Task Force, and the context for it is this widespread concern about the existing system or how we evaluate teaching. And there are lots of versions of that concern. The first one is response rates tanked when we went electronic. Oh my God, the system is broken. The other thing is that, and this is a long-standing concern among many of us, is that the only university-wide metric is the formal course evaluations, which we'll call the E&Es. And almost all research suggests that that's inadequate. A single metric of any kind, however good, is inadequate. And then one concern people often have is the reporting of the data. That even if the instrument is good, or whether it's good or bad, how the information is reported to faculty, administrators, instructors, and so on, maybe could be better. Some people find that as a problem. An important concern for students is that we do not currently share all of our data with the students publicly. There is actually a university policy that students have access to it. It's just technically not done. We used to rely on the students, the MSA, now Central Student Government, to provide it. They are no longer able to do that. Students rely on ratemyprofessors.com, which is not as bad as you think. We can show you. But it's still not ideal. And so there is this concern that it's not shared with students. And I think many of us think that it absolutely should be shared with students so that they can make informed choices about their classes. And then those of us who might sometimes think that, well, let's think about whether the forms that we currently have might be better, we realize that there are, in fact, in the possible question bank, there are 1,078 possible questions you could ask on the forms if you want to tailor your forms. So most of you might not even know that there is this question bank that you could tailor your forms up to 30 questions in addition to the university-wide Q1 through 4, which I'll talk about a lot. So there is this widespread concern. Some aspects of it, like I said, are acute responses to the 2008 shift to electronic collection of data. Some are more long-standing, but this is some of the context. So as the Learning Analytics Task Force emerged, it was part of its charge to evaluate the current information environment that we have here at the University of Michigan. Evaluate the tools that we currently use, and obviously the most important and the only university-wide that we use are the E&Es. We were also interested in evaluating how they are used. So part of this committee, and I will not talk about this, commissioned Mary Wright and Matt Kaplan from CRLT to conduct a study of this, what's sometimes called the consequential validity, how these evals actually are used by administrators, faculty, and so on. And that's a very interesting report. And the good news, in a sort of tweetable sentence, is that people at the University of Michigan understand the imperfection of this tool, and despite that, use it quite well, with a grain of salt. So again, if you're concerned that if you're junior faculty or GSI and thinking that my professors, my administrators will not understand these, don't worry. For the most part, people do understand it pretty well. There are some misconceptions which we hope we can show are actually misconceptions. And then consider alternative modes of evaluating teaching. That's part of our charge in the committee that I've been heading. So thinking about what else could be done. Should classroom observation, should we implement a system that is now used widely with lecturers, and so on. And then thinking about, again, part of the general Learning Analytics Task Force charge is develop better tools for reporting. So some of the visuals that we will be showing today might be ways of thinking about, would this be a better way of showing what your teaching evaluations look like than the current quartiles? Here's your median, here's the college-wide, and so on. So the Teaching Eval project, there are a bunch of people who have been involved in this. The Registrar's Office, in case you don't know, now owns and manages the teaching evaluations, and they have been incredibly awesome participants and collaborators with us on this. So I particularly want to thank Courtney Brisk and Phyllis, who is here. Phyllis provided all our data to us. And for anybody who says that the move to the electronic was a disaster, whether it is, I don't think it was. If you're interested in the learning analytics aspects of it or data management aspect of it, it was great. The paper system was a nightmare, and Phyllis has had to deal with some of that nightmare again because we asked for a lot of data from her, and she was able to provide it. But so there are lots of benefits about the electronic system, and again, thanks to the help from the Registrar's Office, we have this data. One thing I would say is that, and this seems to be the sort of continuing refrain with all of these learning analytics projects, is that big data is messier than you thought it was going to be. You thought it was going to be messy, but it's in fact even messier. So much of our time has also been trying to make sense of it, trying to clean it up, trying to think about, trying to avoid mistakes, and so on. All we'll do today is talk about the E&Es. So I'm happy to hear suggestions that we should change the kinds of questions we ask. I think that that might be a reasonable thing to do. We should do something else. I think that would be reasonable too. What we are now looking at, what the current system that has been in use for a long time is doing, what can we learn from that, and so on. So what do we have? What is the data we have? We did not get the entire university-wide data for lots of reasons, and especially as we go to smaller units, the ways of thinking about teaching becomes relatively idiosyncratic. So we decided to opt for the big two. So we have all of the teaching evaluations for LSA and engineering from winter 05 through last winter. That is 107,000 courses, course units, which means labs and discussion sections, for 13,801 instructors, including both lecturers, tenure stream faculty, visitors, and graduate student instructors, and so on. We also have, as we were waiting for the data last winter, David went and scraped the entire ratemyprofessors.com. And so we have all of the ratings from ratemyprofessors.com, which is 30,000 courses for 3,100 instructors. What do we know from that? Well, the likelihood of as an instructor, having a rating on ratemyprofessors.com, first of all, is about 0.3, or in fact less. So most people don't have any ratings. Most of the ratings are, on average 10. In fact, Some people have just 1 or 2. Very few people have lots. So it's very imperfect data, but we did some things with that. And if we get to it, I'll show some interesting things about that. All right. So let me start with some descriptive statistics. And if at any point you don't see some of the data or have questions, feel free to ask. So first of all, a common complaint is that focusing on Q1 through 4 misses really important stuff. So if you've served on a junior faculty's third-year panel or teaching award committee, on tenure review committee, or anything like that, and you've had lots of information, you almost always have started just looking at the first 4 questions. And the complaint about that often is that that's not enough. It misses something important. Our answer to that, and I'll show you why in a moment, is that, well, for formative purposes, for instructor to learn how she might think about her teaching, certainly focusing on the first 4 is inadequate. At the same time, for summative purposes, focusing on the first 4 might be helpful. Now, you might be wondering, what are Q1 and 4? I don't remember. So here's where they are. Q1, overall, this was an excellent course. Q2, overall, the instructor was an excellent teacher. This phrasing is frequently complained about, and maybe for good reasons, but that's what it is right now. Q3, I learned a great deal from this course. And finally, Q4, it's sort of an interest or motivation measure. I had a strong desire to take this course. And why do I think that focusing on Q1 and 4 is not as problematic, at least for summative purposes? Well, here is a very widely zoomed out data correlation matrix of just LSA fall 2011 of all the questions that LSA relatively regularly asks. Underneath these localized regression lines are actual plots, but this is zoomed to like 0.1% of the size of the chart. So here Q1 through 1, 2, 3, and 4 are up there, and here are all the other questions. Even at least in the front, you can see that there's some pretty much positive correlation among them all. There are a few that look completely messy. So for example, this line, and this is because it's asked very seldom. We have something like 9 data points for that. So, the lines look crazy. So instructor acknowledged questions insofar as possible. So the N is very low. That's a very good question. It's actually a question that was originally put on the form at the request of the students. It's just not used very widely. Another quite messy one is grading was clear. Again, we have very small n. That's a very good question, very small n. The one thing that does not correlate at all with any of the other questions, so the regression line, localized regression is pretty much completely flat, is workload. So this is good news, right? Don't worry about workload hurting your evaluations. This suggests that it doesn't. So this is my quick apology for saying, okay, we are also just going to focus on Q1 through 4 in what follows. So first, it would be interesting to see how professors fare compared to GSIs. We don't actually have the HR data about people's appointments. We will have access to it eventually. So the closest proxy that I wanted to do was comparing discussions to non-discussions and excluding labs. For the most part, discussions are led by GSIs, not uniformly. For example, some departments where faculty really care about teaching, like history and philosophy, professors lead some discussion sections. And of course, GSIs teach lots of things, like English 125 is largely taught by GSIs and so on. So this measure is not going to be perfect. But what we get, and this is a Q2 comparison, so I was just interested in what do people say about the instructor quality. On the left is average median evaluation, and here are the N's, and each N is an instructor course term. my teaching this course this term, not my teaching this course in general, my teaching this course this term. These are courses, so rough proxy for what we might say permanent faculty. Junior faculty know that that's kind of ironic to use that term, but non-GSIs, and then discussion. There's no difference in engineering. Engineering has very few discussions, and I actually, to be honest, I don't know what engineering does with discussions. I mean, this is not a sort of critical or sarcastic question. I don't know. I know you guys have a lot of labs, but I don't know what discussions are. In all the other, in the LSA divisions, humanities, natural sciences, social sciences, significant difference in favor of the more seasoned instructor, which is, I think, the most obvious hypothesis that comes to play. So among the people who lead discussions, most of the people have a lot less teaching experience. They are also often caught between the rock and the hard place. They are teaching somebody else's course, so that course might be good or bad. So that's why I just tried to isolate that effect by looking at Q2, and that's what we get. So there's some difference, some significant difference. It's helpful to remember that. If you are a graduate student and go to a professor and say, look, here are my numbers, and your professor said, you must suck because mine are better than yours. This is actually a university-wide, at least LSA-wide systemic feature. Another very common question, yes?
Those asterisks,
they were significant.
Okay.
They were significant. So I ran t-tests on these numbers and wanted to make sure that they are, that the difference isn't just, oh, and I should say, so here are standard errors, and this is just the t-test significance.
Scale on that? So is that going up to?
It's going up to 5, so 5 is here. You will see in much greater detail in a moment how little variation there is university-wide. So it's important to remember, one person once did this sort of meta study of all of social science, and they came up with 3 conclusions of all social science. Number 1, some do, some don't. Number 2, differences are smaller than you think. Number 3, it's more complicated than that. And I think that's true about this here too. So it's important to remember that one widespread problem about the use of the college-wide quartiles comparing your medians is that to remember that the differences are very small. All right, so gender. There is wide evidence from higher education in general that gender makes a difference in various ways. Sometimes women are seen as punished. For example, in fields where women are a smaller minority, or they are not seen as competent, or something like that. So we were interested in seeing what kinds of gender effects we have. Q1, again, left, engineering, humanities, natural sciences, social sciences. Full scale, 0 through 5. No difference. So natural sciences for Q1 looks like the only difference. It's not significant. I ran a t-test on it. So on Q1, overall this was an excellent course. No gender difference at the University of Michigan, which is good news. On Q2, overall this was an excellent instructor. No difference in engineering, no difference in the humanities, significant difference in favor of women in natural sciences and the social sciences. Quite significant in the social sciences, which depresses me because that's where I am. Now, there's, yes?
I have a question. Does this include both the discussions and the lectures?
Sorry, this is only lectures. So this is just lec-rec. So the course component is lecture or recitation. Primarily professors, in some cases lecturers. Yes?
Why did you restrict to the courses with more than 30 evaluations, and how many, like what are the ends on?
That's a very good question. So the problem with the response rates is that the variance on, if there are fewer than 30 evaluations, it's a crapshoot. We'll show you in a little bit. So most of this data is on in a more than 30 evaluations turned in per course. The response rates, I'll talk about that in a moment.
So you did this analysis then on a median course score as opposed to each individual score that each student gave them?
Right. Yes. Yeah, it's on median course scores. We in this data, we don't have the individual. We have, and you will see in a moment, we will have this many people strongly agree, this many. So that's the finest grain we have. And that's actually going to be super interesting once we get there. Yes?
Discussions for us at least tend to cap at 20 or maybe 25, and I suspect that may be true in a lot of the LS&A courses too. Does that mean that essentially those courses aren't represented?
Those courses, and these are actually excluded. So this is only recitations and lectures. So it's labs and discussions are excluded from this data because for the most part, we are focusing on, again, permanent faculty as opposed to graduate students. And,
Just
yes,
one little follow-up. You said recitations.
that's,
as
yeah.
opposed to discussions and
Recitation is the official code for type of course. I actually looked it up this morning because I've been using it for years, but I didn't know what the difference is. Lecture, the official description is lecture is primarily one-sided discourse to students. Recitation, largely interactive, but no additional components. So no labs, no discussions. So it's basically upper level versus lower level, large versus medium size. That's the difference.
I
Susan?
have another question. Do
Yeah.
you have any way of separating this out into tenure track, non-tenure track?
Eventually, not at the moment. So adding the HR database to this is going to probably drive Phyllis to her grave, and we don't want to do that. We will do that. It's really important. I don't want to dismiss that question. I think it's really important, but it's complicated because also the HR database works with a very different logic from the rest of the database. It's all in the same data warehouse. But so appointments can change at various points. So if I look at, you're full professor now, but if I'm looking at your class 10 years ago, I don't want to say that full professor. So that's one of the things that we want to be able to control for. So that's just is something that we haven't been able to get to yet. So, one more thing I wanted to say about this is that in the conversation about student ratings in the literature, there's a lot of discussion as to what counts as bias. So here we have a gender difference. And somebody might say, well, here's an easy example. If this had been not in favor of women, and let's say it was significantly so in the natural sciences, we might say, well, the scientists are just sexist jerks. If that were the case, that's not true, but if that were the case, we'd say that's bias. But then there is, in fact, lots of evidence in the literature showing that women and men, on average, have slightly different teaching styles. So then gender difference is actually no longer exogenous bias that we should control for, but something that we should know. So in what I'm talking about, I don't want to say that this is a bad thing or a good thing. I'm just reporting here's what's happening. And for the most part, I'm going to go somewhat more fine-grained in a moment. Thanks to stuff that David did last night at 4 a.m. But for the most part, we're trying to stay with relatively high end because even with 13,000 instructors and 107,000 courses, we cannot start revealing, or even implying who we're talking about here. So we'll stay at, some level of abstraction throughout. All right. So here is the only clear, widespread misconception that comes up all the time. It also came up in the report that Mary Wright and Matt Kaplan did for us about how administrators and faculty use evaluations. This idea that there is a correlation between grades and evaluations. Well, for engineering, no, not at all. In both cases, here's top row engineering, bottom row LSA. There's a regression line, and then median and confidence intervals. So in LS&A, very, very small positive correlation. But if you look at the data, it's one big poof ball.
Is that true true of your evaluation data though too? I mean, your N is big enough to get the error bars down, but you didn't show the data for the, we just showed the histograms, but I'm
Right.
guessing that data is just as noisy on that Likert scale, 1 to 5? No?
No, it's not.
Okay.
We actually have some of that, but right. So those were the error bars. If I had done the standard deviations, yes, there's actually a lot of variance. So in fact, so here is a grading course. Here is a variance on. So it's pretty interesting to think about. I don't mean to pick on you engineers, but here is something interesting. Everybody in this class gets an A and the instructor is rated as lower than 2. What is going on? Like, with all due respect, some people need to be fired.
We're not quite following what the different lines are. Can you just?
Okay, so here are simply just the medians of the
So
evaluations.
what are all the points?
Points are instructor course term. They are, so courses taught this term or that term or
Oh,
and
I see there's 2 axes.
Yeah,
The
so-
evaluation score and the.
yeah. So here's an average grade. So further right, higher grade. So one thing that is widely known is that if you look at just the x-axis and where the centers of the proof balls are comparing here, this is a Q4. I had a strong desire to take this course. And grades are always a little lower in engineering. So a little bit, not much, but a little bit, yes.
One Statsky question.
Uh-huh.
Can someone throw out the range of R squares or pseudo R squares that we're looking at here?
Did you do them?
So, no, not for these.
Okay.
These graphs.
Right.
Yeah.
Yeah, so the question was about how strong the correlation. These are relatively small correlation, but we didn't actually run the numbers. We just wanted to give you the slopes. So these are relatively small. What's really interesting and what's kind of depressing is that if there is one measure we would want to correlate with grades, because if we assume that grades reflect the learning, I learned a great deal from this course. No correlation whatsoever. In engineering, the higher the grades, the more students think that they didn't learn anything. But again, I don't want to exaggerate that because the slopes are relatively minimal.
In LSNA, that's all of the domains linked together.
Right. This is all of LSNA.
So presumably, if you broke that, I mean, natural science must live slightly to the lower left versus humanities and social
In terms of the grades,
Right.
yes. Right. So, question about LSA. We didn't break this down by divisions in LSNA. STEM in LSNA does get slightly lower scores, grades than other fields. Okay. So, the overall conclusion in engineering, your students understand that there's no point in punishing the instructor regardless of what grade they got. In LSNA, a little more, but again, not significant. And instead of looking at the slope of these regression lines, so the steeper the slope, the stronger the correlation would be. Again, I would look at this big cluster. It's all over the place. So maybe for you, it seems like it happens, but maybe not for somebody else. Okay. This is the most common complaint that we've heard since winter '09 in particular, when the system crashed. And here are the response rates for engineering and LSA. Blue is paper, old system. Red is electronic. This dip is winter '09, when the system crashed, where literally most people were not able to submit them, even if they wanted. Folks rallied commendably out of that trough, and then it's stabilized roughly about 15 to 20 percentage points from what it was. LSA used to get higher than engineering, remains slightly higher, so that difference. So it's about 15 to 20 percentage points less than what it used to be in the past. But what's pretty interesting is that when we start breaking it down, well, humanities in LSNA used to have fantastic response rates. Why? One hypothesis is that humanities has the smallest number of large courses, largest number of medium-sized courses where students are rewarded for coming to class. When you had the old paper system, people did it in class. So if you made them come to class, they would probably do it. And we'll see this again. Since going electronic, humanities varies just with all other LSA divisions. If we break it down by course component, so here is recitation. Again, in most cases, upper division, instructor taught, standalone, medium-sized lecture courses. Seminars, labs, discussions, and lectures. So people weren't really responding to your teaching evaluations if you had a lecture course in the past either. So that there the difference is less than 10 percentage points since going electronic. Whereas, again, in some other types of classes. So again, the obvious hypothesis here is that if you made them come to class and you had them do it in class, they would do it. But if they didn't come to class in the first place, they didn't come and they didn't care. None of this is to say that, well, so let's not worry about it. The interesting question is to say, well, what happened to ratings? There are a couple ways I could show this data to you, so I will. The first one is nothing happened. Blue, paper, red, electronic. But here, Edward Tufte would start kicking me and pointing out that, dude, didn't you just tell them the differences are small? So here I'm operating with the full scale, which is 0 to 5. And if we're looking at it in that sense, it doesn't look like anything happened.
Can they see that?
Yeah, can people see it? So this is discussion, labs, lectures, recitations, and seminars. Y-axis is years. This is winter of 5. No, sorry, Y is, X-axis is for each row, it is 0 to 5. So 0 to 5, 0 to 5, 0 to 5, 0 to 5. So one might think, oh, not much happened. But in fact, now isolating engineering from LSA and focusing on lectures and recitations with more than 30 evaluations turned in, the differences begin to seem significant and really interesting. So this is something I want to spend some time on. The dots are the mean, the averages, and the bars are the standard errors. So obviously, in winter 09, when the system crashed, not very many evals were turned in, so the error is very large. A couple of interesting observations, and we'll spend quite a bit of time on that. First of all, engineering, I had a great desire to take this course. So these are now in proper order: Q1, Q2, Q3, Q4. Overall course, instructor, I learned a great deal, and I had a great desire to take this course. In engineering, the numbers have been going up a lot. Two possible hypotheses. You're getting a selection bias. Only the people who had a great desire to take this course are bothering to respond. More interesting, and maybe for you guys more sort of flattering hypothesis, something is happening in engineering, that this is actually a reflection of some exogenous effect of students realizing that, whoa, we are getting jobs, unlike those LSA schmucks. I didn't think this class was going to be good, but now I have a great desire to take it. So that's just, these are just descriptive statistics. I don't know. I mean, and we don't have any immediate way of testing that kind of hypothesis. So again, what you see is interesting variance. One thing I point out, and again, I apologize for the poor projection in this nice engineering building. But there's a systematic, not significant, but systematic difference between fall and winter, which is flipped between engineering and LSA. And the sort of immediate hypothesis is that, well, the data is driven by freshmen. Freshmen get to register last. They have to take courses they didn't really want to take, or they don't know how to use the system. Freshman courses don't account for most of this. So that can be fully driving the data. So I just want to raise this. And then I want to do a super quick aside to our ratemyprofessors.com data. This chart shows the likelihood of receiving a good review with 95% confidence intervals as the whiskers of these things. So even on ratemyprofessors.com, you might think that they hate me, but in fact, the likelihood of getting good review there is really great, always greater than 0.5. So in general, it's about 0.6. And this is all of them averaged over a calendar year. So at what point during a calendar year did students fill out these evaluations? So these are weeks of the year. Here are the months. And here the two significant dips are welcome to exam time. We don't know whether it's because they had to study for this goddamn course or because they got a bad grade from their exam. We can't get fine-grained enough about that. But it's just to say that timing of these evaluations matters. Also, in an annual or per term basis, and then back to this data apparently between fall and winter. So far, we have had no way of sort of even thinking about that. And I just flag it as something that we might want to think about. How do we account for that? How might we control for it? And so on. All right. Now, what we have here is, again, Q1, 2, 3, 4. Lecture, discussion, seminar, lab. Red, % strongly agree, % neutral. So this is the distribution of the evaluations, not just the medians. A couple of obvious things that we can tell from this data. For instructor, it's almost everybody thinks that the instructor is great. So for the most part, the agree and strongly agree are the ones that drive the data, which of course is obvious since the numbers are so high. And the break in the data is going electronic. So this is actually not uniform. So the numbers remain roughly the same, but if anything increases is the number of strongly agree increases as we go to electronic. And this suggests, whether it's a problem or not, the comparability of paper versus electronic becomes weaker because you're getting, in some ways, slightly different populations. The students who like you are more likely to respond. Yes?
So the response rate as a question, that's something that's concerning me, especially because I do discussion sections and there's small amounts. So I've had semesters where I had 30 students in my section and only 4 responded.
Right.
And but I remember when I was at Rice University, you couldn't get your grade until you filled out the online evaluation. Why isn't something of that sort implemented?
That's the question that 7 other people at least here were going to ask. It's a good question. So I don't know if any of you folks from RO want to talk about this, but right now the RO's understanding, interpretation of Michigan law is that given access to public records, we cannot withhold student records from them. So that's why we are not doing that yet. Now, interestingly, the General Counsel at Michigan State interprets Michigan State law differently. At Michigan State, you are required, you will not get your grade until you turn in your evals. So I see either a lawsuit brewing or something that we need to talk about. Right, so that's the obvious thing, that how do we incentivize better response rates? I think that's an important issue. It's a conversation we need to keep having, but it does require something more than just sort of looking at data. It requires some policy decisions or policy interpretations. So it's a very good point. There is, my colleagues who do survey methods will point out that if you require it, you are also changing the nature of the data. these jerks are making me do this thing during the week when I'm already busy. I'm going to punish this guy, even though it's the university policy. So again, it's a complicated issue. Yes?
So speaking to that, do you have any way currently to parse out which of these were required as opposed to extra credit, et cetera?
Which of these
So in terms of
evaluations?
sources made, the evaluations.
Do we have a way of parsing out which were extra credit or which were required? So nothing can be required. So no evals have been required. No instructors are. They have no mechanism because they do not know unless somebody is really into collective punishment, which is like if this class does not get to 70% response rate, everybody's going to be punished. And I don't think that would work particularly well. So we have no way of parsing it out. And in fact, one important policy suggestion we have is that at the moment, student identity is permanently severed from the evaluations. So all our data, even the grade data, it was per course average, per course average. Wouldn't it be awesome for me to know how did Tertia, who got an A+ in my class, rate me as opposed to Deb, who unfortunately got a B-. So that would be really important. It's not data we would ever want to share with the instructor, but for learning analytics purposes and sort of understanding how these things work, it is now technically feasible to do that. We currently don't do it. Yes?
Is it technically feasible to add one more piece, which is what grade did the student expect to get?
Yes, it's already in the evals, and we actually did that. We did some couple of semesters. Evaluations that correlate strongly with the grade, with a slight inflation. Student expects to get a stronger grade than they did. Right, yes?
We have made a transition from voluntary to required evaluations at the medical school over the past year. We've seen a slight decline in evaluation averages following that requirement. So it's just something to think about. Be careful what you wish for.
Right, exactly.
And then the other piece, talking about respondents versus non-respondents, having done some analysis on who responds versus who does not respond, we found that those who respond tend to be higher performers in terms of their grade in the course.
Right.
So I think that is also conflated with course satisfaction, performance in the course.
Right.
So different group of respondents, different population, but I think it's something to think about.
I agree. So the 2 points that about requiring them, they might go down. Right now we have a slight uptick, right? So the number of strongly agree goes up. If we require them, we'll probably see a different sort of effect, where they biases the population differently. And then in general, just sort of thinking about who responds. We know from ratemyprofessors.com that for the most part, people who like you respond. Then the second likeliest group to respond are the people who hate you. And the people who are like, don't bother. All right, I'm gonna go through a couple more things. So here is the same numbers. We just ran it for a couple of different departments. So English, history, psych, economics, English, history, psych, economics. So again, serious instructor inflation in English. They love those folks there. And this again seems to indicate a kind of a selection bias, that what goes up is the number of people who like you since going electronic. Otherwise, it stays relatively flat. There's a lot of variance, and these are department-wide, and none of these are small departments. So it is interesting to think that there is a lot of noise in the system. So again, I'd suggest that any department chair or deans don't fire anybody on the basis of their performance in a single term, because there's clearly a lot of variance sort of from term to term. This is the same for math, chemistry, physics, and bio, in LSAs, the STEM fields. So the numbers are lower, but we see upward movement going electronic. So again, the population changes a little bit. A couple more quick things. because the response rate is really not as important in some ways as the actual numbers. And here are just a couple of quick ways of showing it. So here are all lectures and recitations starting with fall 08, so all electronic. And the chart here is that same course taught by the same professor from one year to another. Here is evaluation on year T. Here is the evaluation on year T1. So another way of asking this question, how well does my teaching this very course last year predict my evals next year? All courses, including smaller courses, evaluations often relatively small, that R squared is 0.41, which is another way of saying not all that well. It matters, which we would hope since I was the same person, but not that much.
Which question is that?
Q1. Overall, this was an excellent course. For large courses, and this large now is more than 70 students, which is what the registrar's office calls large, the R squared is 0.65. So in fact, it's a pretty good predictor. We'd be really depressed if it were 0.9, because it means no matter what you did from year to year, even your attempts to improve made no difference. They just loved you or they hated you. So this is, you have, as a professor, has an effect. How you taught lots of students. If you had lots of students, what they tell you tells something about you. Now, do we pry apart the course and the professor? Well, there's obviously lots of endogeneity between a course and a professor. In most cases, even courses under the same number are not using exactly the same syllabi, so professor has a lot of effect on courses. There was a question, yeah?
So is that 70 enrolled or 70 responsive?
This is 70 enrolled. So for this, so maybe the final thing I will show you is consistency of evaluation over time. This is now for Q1 through 4. This is greater than 50 respondents, fewer than 50 respondents. The steepness of this blue slope is an indication of the predictive power of you. And this is now professor, no matter what you taught, right? As long as it was a course larger. That's right, David. This is professor, not professor course.
That's professor, right?
Right. So if you teach 2 large courses, we just look for you.
This is just taking every professor, looking at all their evaluations, summing them up prior to fall 11, and then comparing to their evaluations to post fall 11, and weeding out those with small numbers of responses, just to see if there's some level of consistency such that if you did poorly in the past, you do poorly in the future. That's basically what it's.
Right.
So there's a few years of data before fall 11 and 2 years afterwards.
There's actually a lot more data prior to fall 11, which was a choice I made. I originally wanted to do how well would your previous scores predict a single semester, but I wanted more data. And so I wanted to include both the electronic and the paper, and this is
Right.
what I came.
So this is 05 through to 11 and then 11 and after.
Yeah.
So there's lots of data prior.
So what's the blue line?
Blue line is the regression. So the steeper it is, the better the prediction. So
Okay, so they're all lower than, they all have a lower slope than
Right.
the line that is drawn through them.
Yeah,
Right.
which, I mean,
What does that
Suggests
mean?
that we're dropping, right?
Yeah,
It says
that's
that
a-
we're
yeah, that's. I mean, I don't know if you really want to take it that seriously, but it's yeah. It says that the scores post fall 2011 are a little bit worse than the the scores treat as
I
well.
think it's a statistical artifact that'll happen no matter
Yeah.
whether
Right.
scores are increasing or decreasing.
That's
Right.
I don't think it implies anything.
Yeah.
Right.
It just means there's some error there.
Right. So the key here is to think about the the angle of the slope. The steeper it is, the better the prediction. That's the key point. And I.
As it goes along the 1-to-1 scale, then it's a better predictor. So you can't see it, which is a problem with some of these graphs. But there's this a line that goes along the 1-to-1 from corner to corner, and so the idea is that as close as it gets to that line, the better these scores are for predicting your future scores.
So if you go back one to the one that's year t and year t plus 1,
Right.
the line that's drawn is exactly the line of best fit appears to be exactly a 1-to-1 relationship.
That's
Right.
right.
That's just the 1-to-1 relationship. We didn't draw the correlation there.
You didn't
So,
draw it.
so it's just that this number is a numerical representation of what that line would look like.
And if we wanted to believe that we got better the second time we taught a course or the third time we taught a course, we'd actually expect the line to be better than that diagonal. And
Yeah.
it's even
Right.
slow.
Exactly. All right. So I also had some cool stuff from Rate My Professor as well, cool and depressing, but I think we'll leave that for the next time. We'll be happy to share any of these slides. As you know, this is getting videotaped, video recorded, and we can't share our data with you, but we're more than happy to share the methods and the techniques and the R scripts that we used. And if any of you have any suggestions down the line, please let us know. Now we have about 15 minutes for Q&A, additional Q&A, so the floor is open. Steve?
Mika, did you guys do any analysis comparing graduate course evaluations versus undergraduate?
No. Did we do any analysis comparing grad to undergraduate? No, we did not do that. So most of this, for the obvious fact that the largest number of courses, and especially, so basically all of our data excludes grad seminars because we are looking at evaluations greater than 30. So looking super quickly at the data, grad seminars tend to be higher on average. The ends in terms of the response rates vary hugely, and they tend to be very small, and they also suffer from the drop.
You are going to, I mean, there's going to be some mixed in with, like medical school and like larger master's programs.
Right. So this is just COE and LSA. So.
Okay. Oh, okay.
So obviously that would be interesting. We had law at first, but their data was very messy, and so for the purposes of this is basically in some ways a pilot of getting some of the sort of phenomena in relatively well understood 2 large colleges, and now we can go forward. Gus?
So I have students in my class scraping Rate My Professor to look at perceived easiness against perceived quality. And I'm curious to know, have you looked at quality in Rate My Professor versus Q2 in Okay, thank you.
So this is actually not that. So this is just RMP. This is just Rate My Professor. They have Rate My Professors has 4 measures: easiness, professor clarity, professor helpfulness. Professor helpfulness of professor clarity is indexed into the overall professor quality. Now they have rater interest, which we are not including here, and then the infamous chili pepper. The professor is hot or not. So here is easiness, here is overall professor quality. Even on ratemyprofessors.com, students are capable of differentiating easiness from the professor quality, which is good news about ratemyprofessors.com. On ratemyprofessors.com, if you don't have a chili pepper, you have to go from being a real hard ass to as easy as the hardest ass hot professor to get the same quality rating, which is really problematic, right? There are lots of interesting questions. So one of the things we did not do is we did not look at every department website and just code these people like, yep, correct, hot, or not. And not just because I don't have enough money to pay David to do that. But there's a lot of discussion in, the teaching evaluation literature, and I did an unscientific survey which is asked former students every setting I can, show them this phenomenon, and almost invariably they say, Yeah, it's not that I think that they're hot, that they are nice. So and there's this concept in the teaching rating literature called rapport. And we think that the chili pepper, if it tracks anything, because it clearly is tracking something that, which is endogenous with quality, but not the same thing. We think it tracks something like rapport, accessibility, friendliness, things like that. And it's problematic that this commercial tool objectifies and sexualizes it, but it's an interesting measure. And then here's the depressing thing. We did match people rated hot and not hot with our data, because we have people's names. Because RMP relies on students' ability to type our names correctly and they never get me right, our data set, our match is very small. It's about 715 individuals. You can't quite see this, but red are people who have chili pepper and RMP. Black are people who are on Rate My Professors but who don't have a chili pepper. This is Q1, right? This is Q1, and here's Rate My Professor, Professor Quality. Here is University Mission Q1. So what does this tell me? If you come and tell me, hey, I got a chili pepper, I can tell you your UIM evaluations are pretty high. If you tell me I'm not on ratemyprofessors.com, which is the likeliest thing for everybody, or I didn't get a chili pepper, I can't tell how you do on anything else. So that's the one thing we know. So it does measure something. But again, we think it's something, it's probably not looks as much as rapport. Yes?
Do you or do people who do Rate My Professor happen to know how it breaks down along sex lines?
So we don't know that. So we weren't able to control for that. We do know that, again, anecdotally or looking at the data, is that there is no obvious men rate women, women rate men only, or something like, or that it has something to do with sexual orientation or anything like that. Yes, sir.
So, what's the takeaway message from all of this?
So
I'm sitting here trying to figure out what I should do tomorrow. Monday.
Right. Yeah. What is the take?
Red hot.
What is the takeaway message in general? So I guess part of the point here is to say that when people say the system is broken, it's not obvious. So this is a very imperfect system. We might think about whether to change the questionnaires. Would other forms of questionnaires be better? Rate My Professors, one virtue of it is it's quick. It's 5 questions. Effectively, we ask up to 30 questions. Should we think about restructuring the form? Another thing is timing matters. We right now ask the questions at the end of the term for the obvious reason that that's when students have a sense. Should we actually ask it a year after they took the course, a semester after? Should we have an ongoing on your course website, this week I'm liking this, this week I'm hating this, or something like that. So timing matters, and how do we get better data? Well, somebody might say the worst possible time is when they're busy and stressed out about final exams. So that's one takeaway. And again, what I would argue is that the system is, as it is not broken. Going electronic did not break it, but it's helpful to know some of these things, that some of the kinds of covariances as to what's happening, so that you should always try to get as high a response rate as you want. If you care about knowing how am I as a teacher, you should actually teach as many students, not just get the response rates up, because if you get 20 students seminar from semester to semester, it could vary widely. A 70-student course from semester to semester is not. So if you think that we don't know, we haven't said a word about these measuring student learning, your actual goodness as a teacher, we don't know that. But if you want them to measure something consistently, you want to teach as many students as possible and get them to respond. And the university needs to think about how could we improve the system that's not broken but might be improved.